For this video, we are going to look at what we call inverses of relations and functions. So we will graph and recognize inverses of relations and functions. And for your focus, you're going to be able to graph an inverse of either a relation and or a function. So let's take a look. We can find those inverses of relations and functions, and remember, relations are just your set of ordered pairs, where your function, however, is that x value only having one y value paired with it. We are going to graph those inverse relations, and the way we graph them is really just a reflection, and we reflect each point across our line y equals x. And if you'll remember from geometry, when we reflected over the line y equals x, that was the same thing as switching your x and y values in each ordered pair. So in other words, if you started off with your ordered pair of x, y, once you reflected it, the new ordered pair then would be y, x. Okay, let's try it. So here we have a relation. So we're going to graph our points. Okay. And then we're actually going to connect them. That's the first thing we're going to do. And so we'll have a visual of our points. And now we've gone back and connected them. Next, then we're going to graph that inverse. So remember what I just said. That is basically taking those x and y values and switching them in the ordered pair. So our new table would look like this. You see how the 0, 2 is now 2, 0. The 1, 5 is 5, 1, and so on. And so now we're going to take our new points and we're going to reflect them over that line of y equals x. So here's our line, our y equals x, that we're going to reflect over. And now we're going to plot those new points. Remember, the new points are the 2, 0, the 5, 1, the 6, 5, and the 9, 8. And here in red is your inverse graph. And it's as easy as that. You have graphed it. And remember, when you reflect something, remember that the points are the same distance from that line of reflection, being that of y equals x. And if you look at your points, you can tell that they are in fact the same distance from that line of reflection. Now what we're going to do is we're going to look at the domains and range. We're going to start off with our original, that was our blue. So if we look at our original domain, we started here at 2. We're going to look at 2, and we went all the way up to 8. So our domain of our original relation was between the points 0, 8, and of course they were included. Now let's look at the range. So let's come up here. So we started here at 2, and we went up to 9. So there's our domain and range of our original function, the domain which went from 0 to 8, including the endpoints, and the range that went from 2 to 9. Now let's take a look, and I think you'll find this interesting. Let's take a look at the domain and range of our inverse. So let's start with the domain. So we're right here at 2, and we went to 9. We started at 2 and went to 9. Look at the range of our original relation. You see something interesting there? And now let's look at the new range of our red one. So we started here at 0 and we went up to 8. 0 to 8. Does that sound familiar? Look at your domain of your original function. So you see what happened. And this should make sense to you when we switched the x and the y. Remember when we started off with x, y, and when you reflect it, you end up switching your ordered pair to y, x. In fact, that also affects the domain and the range of your original and your inverse. So you see that your domain of your original function actually, or relation, actually ends up being the range of your inverse, and your original range actually ends up being the domain of the inverse. And that should make sense to you. If we were switching the x and y, then in actuality, the domain and range also get switched as well. Let's do another one. So here's our relation and our table. So let's graph those. So here's our points graphed and connected. And you know what I would like for you to do? If you would pause the video, and can you figure out the new ordered pairs? Can you make that switch for me? Write your new table and graph it, and then after you do that, turn the video back on, and let's see what you have. All right, so hopefully you have that graphed, and if we switch the x and the y, look at your table. So our 1, 0 now became 0, 1. Did you do that? Our 3, 1 became 1, 3, and so on. Did you get that? Now, what does your graph look like? Does your graph look like this one that we just did here on the PowerPoint? I hope so. And you can see that when we reflect over that line, y equals x, and you look at the distance of those points to that line, they are the same. So now let's talk about the domain and range. So let's take our original first. That was our blue one this time. Our domain started here at 1 and went to 6. And the range started at 0 and went to 5. So our domain went from that 1 to 6, and our range went from 0 to 5. Again, those endpoints are included. Can you predict what the domain and range will be of your inverse? Will the new domain be between 0 and 5? Let's try it. All right. So our new domain, so let's come look here. We start at 0 and we go to, sure did, went to from 0 to 5. Is our new range going to go from 1 to 6? Let's see. Sure enough, we're going to start here at 1 and we're going to go to 6. And so there it is. It happened again. Your domain and ranges switched as well as the x and y, right? So remember, when you reflect, not only do you switch the ordered pair, you also switch the domain and range. All right. I would like for you to do this one on your own. You're going to do the same thing we did with the two examples. Graph it and connect your points, then graph your inverse, and then identify the domain and range of each of them. Bring this back to class along with your notes and along with your whisk. The whisk should be posted with this as well, and I will see you in class.